So if I were to ask you a question, if I asked you, what is the mass of a single water molecule? Raise your hand if you think you could correctly answer that question. What is the mass of a single water molecule? Edis? But I'm asking you for the mass. Can you tell me what it is? No? Sean, could you?
3 AMU.
No? No? So we're just guessing, right?
No, I know.
So if we think about the question, I want to know the mass of a single water molecule. How could you figure that out?
Oh, you find how many molecules there are?
I'm telling you there's one water molecule. Diksha?
Find the mass of the atoms.
Okay. So how, if we did that, what would we find? What's the mass of an oxygen atom? Edis? 16 AMU. What else do we need?
Hydrogen.
How many?
2.
What's the mass of a hydrogen atom?
1.
1 each. So what's the total mass of a water molecule?
18.
18 AMU. What's the mass of 14 water molecules? I mean 4 water molecules. 18 times?
72.
72 AMU.
No,
All right.
72 AMU.
That's what we are doing in this section. So we're going to talk about how we actually can calculate the mass of a compound. And you guys understand, based on that, sort of the idea behind it. But as we get more complex compounds, it becomes a little more difficult, so we need sort of a procedure to follow in order to find that. So first off, some terminology. So when we write a chemical formula such as this, remember, H2O, that's a compound, right? It's a combination of one or more elements chemically bonded together. And when we're writing these chemical compounds, we have 2 types of numbers that we put in the formula. There's the large number that comes before the compound, and there's these smaller numbers that go below. The one that comes before is the coefficient. Basically what it's telling you is how many molecules of this compound are we talking about. So in this case, we're talking about 4 molecules of water. What is the subscript telling you? Colin?
How many hydrogen atoms there are?
Yeah, it's telling you how many atoms there are of each element. So this 2 goes with the H. There's nothing after the O, so we assume it's 1. So the subscripts tell you how many atoms of each element there are. So using these subscripts and using coefficients helps us to make sort of writing a compound out a little simpler and neater. You could write 4H2O without the coefficient, okay? By just writing H2O, 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 H2O.
Ho, ho, ho.
You could write it without the subscript by writing 4HHO, but it's simpler to just use the coefficients, use the subscripts to make it clear. So what we're going to be doing is calculating out the molecular mass of various compounds. So the way we do that, take this example, Al2O3. We list the elements that are present in this compound. In this case, it's simple. It's just aluminum and oxygen. Next, we write down how many molecules of this compound there are. Now, what is it in this case? No, number of molecules. We would look at a coefficient. There's nothing there, so what does that mean? 1.
1.
Then we look at the subscripts. So the subscript of aluminum in this case is 2. We multiply them together. There's 2 atoms of aluminum in this compound. Do the same thing for oxygen. atoms of oxygen.
Wrong.
Okay. So then, to figure out the mass, we're just going to multiply those numbers by the mass of each element. Now sometimes we have our radicals in parentheses, like nitrate, which is in parentheses, and then a 3 after it. What does this 3 go with? Only the O, right? What does this 3 go with?
The oxidation.
No. It goes with everything that's in the parentheses. So the first 3 is only going with the oxygen because it's a subscript after an element. If it's outside the parentheses, it goes with everything that's in the parentheses, the entire NO3.
Is there like such thing as a, like, so obviously when you have atoms and they have their like valence electrons and all that, and they're trying to find one that matches up to 8 to become
Yep.
stable, is there like a case where they'll become 8 or like, yeah, they'll become 8 but they'll still be like unstable or like have like dangerous properties?
Not usually when it has to do with the electrons, no. Sometimes when we talk about nuclear reactions, they will, and we'll be talking about that.
Because I know you said like hydrogen or whatever.
Yeah, we'll talk about that when we get to nuclear energy. All right, so let's do a more complex example. 3H2CO33. Okay, may seem complicated, but it's really the same process. So first off, how many molecules of this whole thing do we have? Lily? 3. So everything's going to get multiplied by 3. How about for hydrogen? How many atoms of hydrogen are there? 2. For a total of? 6. All right, how about carbon? How many molecules of this whole thing? 3. This 3 goes with everything. What's its subscript? But is there another one to take into account?
Yes. Yes.
This 3 also goes with it. So we have to multiply by both. So how many atoms of carbon are there? 9 total. How about oxygen? How many molecules of this whole thing?
3.
What are the subscripts? 3 inside the parentheses, 3 outside the parentheses for a total of?
27.
So in this compound that we're talking about, there's 6 atoms of hydrogen, 9 atoms of carbon, 27 atoms of oxygen altogether. Our last step then is to figure out the actual mass. So let's look at this example, NaNO3, sodium nitrate. All right, first off, the symbols that we have, Na, N, and O. Those are the 3 elements, sodium, nitrogen, oxygen. How many molecules of this whole thing are we talking about? Just 1. How many atoms of sodium are we talking about? 1. How many atoms of nitrogen? 1. Inside the parentheses. Anything outside? No. How about oxygen? 3. Then we look up from our periodic table of elements the mass of sodium. What's the mass of a sodium atom? See it? 23A. How about nitrogen? 14. And Tyler, how about oxygen? 16. So what do you think I do in F? Multiply the number of atoms times the atomic mass of the element. 1 times 23? 1 times 14? 6 times 16? 3 times 16?
48.
Finally, I want to know the whole mass of this entire thing. What do? Add them up. This is why you need your calculator for chemistry. Total mass of this molecule, 85 AMU. Simple one, HCl. What symbols do I have? Hydrogen, chlorine. How many molecules? Number of atoms of hydrogen? Chlorine? 1. Atomic mass of hydrogen? 1. Atomic mass of chlorine? What? Chlorine. Okay, use that periodic table. 35.
35.
Total, so multiply it out. 1 to 35. Total mass, 36 AMU. Too easy. All right, this next one I'm just gonna like fly through because this one's too easy. So
It's just gonna take a long time to write down.
now this one, this is the interesting.
Oh, yeah.
This one is the most interesting. How are you guys feeling? Confident?
Yeah.
All right, go ahead and try and do this next one, C12H22O11. That would be sucrose. That's table
Sounds
sugar. This is
fancy.
table sugar. Yes.
Salty. Alright.
Anybody need some guidance?
No.
Or we're good? All right, I see. I'm going to stop you though, because I'm seeing the same. Well,
Come check mine.
maybe I'm not. All right, so let me stop you. So most people are fine here, carbon, hydrogen, oxygen. We're okay here with 4. Now, for number of atoms, a lot of people here wrote 12. What is 12 telling you?
That there's 12 atoms in
But what else do we need to multiply by? We need it times the 4. Because there's really 48
actually did it.
carbon atoms here.
If I get it right,
How many hydrogen atoms? 88. How many oxygen atoms? All right. Now we're good.
Wait, no, I didn't. Maybe I didn't.
And most people found the atomic mass, no problem. Now we know how to proceed.
Let's see it. What?
Those calculators pumping.
Oh my god, this is a big money number. How in the world?
See? We ready for the big reveal?
Check mine, check mine.
For a total answer of
I got it.
1,368 atomic mass units.
Let's get this bread, bro.
All right, got it?
Wait.
All right. Challenge problem of the day. The last row.
My shoe fell off.
Can we do
So
it?
you just multiply by
The last row. Nickel chloride. 3 nickel chloride.
Wait.
May the force be with you.
Wait, is it? Is it?
Drew, you have a question?
If you multiplied each atomic mass by 2, then why is hydrogen only 1?
What?
On the chart.
That's the atomic mass
Alrighty.
of hydrogen.
Try that, Drew.
Diksha, you have a question?
In the parentheses, is CI or
Cl, that's chlorine and that's oxygen.
Wait.
This is not an I, people. That is a Cl. Cl. Together, one element. Yes, you're doing the last one. Well, that's a good question.
I see you, coach.
Oh, yeah.
You know what I mean? Time's almost up. Are we ready for the big reveal?
Yes.
Has anyone already got the answer? yet?
Almost there, coach.
Got it, Lily?
Almost
Uh-oh.
done, coach.
Lily.
Coach is in a rush.
I will reveal in a moment.
No, you
The
won't.
suspense is building. Check your work. If you're close, hold off and see if you're right.
Where's CI? Where's CI?
And
Coach, where is CI?
I got it, Mr. Ross.
good job, good job.
Coach, I would have got it right if you gave me more time.
Yeah? You're on the right track, Drew?
Yeah, I always have everything down. Except for that.
It says 57. What is that, 51?
See, it's a 9, but it's a bit faded.
What? Who? That's not a
It's
9.
It's a bit faded. This pen.
You know what, Drew?
I know. Mine said do it.
Any questions? So your homework, you know how to do it?
Yeah.
Yes.
You're going to do it?
Yes.
You're going to love it?
No, coach.
I didn't say that.
The number of atoms? You're multiplying the number of molecules.
Got it.
So 3 times nickel is 1. 3 times chlorine, it's 1 inside. All right, have a wonderful day, students.
I have a lesson, so.
I got
Hey,
it.
every
Audio.
second be
Don't
enjoyable.
my homework.